Ladies and gentlemen, today we're going to address DMA 70, sections 5 and 6. Section 5 is solving equations containing rational expressions, and section 6 is working with proportions and problem solving. So, as we begin, we are working, as I said, DMA 70, sections 5 and 6. Let's start with two simple problems. Let's say we have x over 2 plus 3/5 is equal to 1/10. So we have an equation made up of rational expressions, and we want to solve for the value of what x is equal to. What we're going to do first is what we had done previously in a prior section, is learn to find the least common multiple. We have denominators of 2, of 5, and 10. So we would determine that our least common multiple is going to be the number 10. You're going to take the least common multiple and you're going to multiply it times every term that you have in your problem. Our objective is we want to make the denominators cancel out, and we have a simple algebraic expression to solve. 2 goes into 10 5 times, and here I'm left with 5x. 5 goes into 10 twice. This is an addition. 2 times 3 would leave me with 6. And here the 10's cancel, and I'm left with just the number 1. As I continue to solve, I'm going to move, because this is just like DMA 40, I'm going to move my 6 to the other side. That's going to cancel. I have 5x equals 1 minus 6 gives me a negative 5. Then we divide both sides by 5, and then x is equal to, this reduced is a negative 1. And that would be our solution. It's just that simple. Okay? Let's do another example where we have single terms. This particular one is going to show us what to do when we have a subtraction, and the fact that the subtraction has to be distributed to all the terms that are in the numerator on the other side. Okay, so our three denominators are 3, 5, and 15. So we're going to identify our least common multiple as being the numeral 15. So each term I'm going to multiply by 15, and then we're going to make each denominator cancel. 3 goes into 15 5 times. So what I have left is 5 and then an x plus 2. Go ahead and bring that down. 5 goes into 15 3 times, so I'm left with a minus 3, and then we have the parenthesis x minus 1. Here my 15's cancel, and I'm left with a single 1. So we've taken a rational expression that we're solving, and we've turned it into a very simple DMA 40 problem. We're going to distribute. 5 times x is 5x, 5 times 2 is 10. Negative 3 times x is negative 3x. Negative 3 times negative 1 is a positive 3, equals 1. Now we want to combine like terms on the same side of the equals. 5 minus 3 is 2x. 10 plus 3 is a positive 13, is equal to 1. Let's move our 13 to the other side. 2x equals, that canceled, negative 12. Now we divide both sides by 2, and x is equal to negative 6. Now, the only difference that we're going to have in our next problem is that as we move along to this, we have in our denominators a binomial or a trinomial. We're either going to have a binomial or a trinomial. The first one is a binomial. In the second one, we have x squared plus 7x plus 12. Here is our trinomial, minus 5 over x plus 4. Okay, so as we begin here, our first order of business, is that we are going to look at each denominator. This denominator is factored. This denominator is factored. This one I need to factor. Okay, so remember the way we would factor. We know each parenthesis starts with an x. There's no leading coefficient. 1 times 12 is 12. So let's go to our calculator. Let's go to y equals. We're going to do 12 divided by x. Go down to your second row. I'm going to put y1 plus x, second table, and our middle number was a 7, a positive 7. So we're going to use the 3 and the 4, both positive 3 and positive 4, in our parenthesis. So here I'm going to have an x plus 3 and an x plus 4. So as I'm trying to determine what my least common multiple is, it's going to consist of both an x plus 3 and an x plus 4. So we need to have both of those for our least common multiple. What I'm going to do is I'm going to multiply each term. So I'm going to come up here above and put the x plus 3 and the x plus 4 with each and every term. X plus 3, x plus 4. Same thing here, x plus 3 and x plus 4. Okay, so every term is going to be multiplied by that. Now what I'm going to do is cancel out in the denominator. So here the x plus 3 and the x plus 3 cancel. I'm left with a 3 and I'm left with the parenthesis x plus 4. In the second one, the x plus 3 cancels and the x plus 4 cancels. So the entire denominator canceled. There's nothing left with the LCM we were multiplying by on the top. So I just bring down the 12x plus 19. There is no change to that. Here, my x plus 4 and my x plus 4 cancel. I'm left with a minus 5 and then an x plus 3. Voila, you now have a simple DMA40 problem. We're going to distribute. We have 3x plus 12, 12x plus 19. Distribute here, negative 5x, and then a minus 15. Now on the left, there are no like terms to combine, but on the right side there are. We have a 12x minus 5. So what's 12 minus 5? 7x. And then I have 19 minus 15 leaves me with a positive 4. As we continue, I'm going to move my 7x to the left. I'm going to move my 12 to the right. And for each of these, I do the opposite so they cancel. 3 minus 7 is negative 4x. 4 minus 12 is a negative 8. Then we divide both sides by negative 4. And x is equal to negative divided by negative is a positive 2. Now, one thing I hadn't mentioned yet, and since we're doing this particular problem, when you have a variable, you always need to keep in mind when you're doing a problem, what would make this undefined? X cannot be equal to a negative 3 or a negative 4. Those would make it undefined. So what you always want to do is to take your answer and check and be sure it does not meet the criteria that makes the rational expression undefined. If it did, If it were one of those numbers, I would give an answer of no solution. If I had multiple answers and if one of those was an answer, you would not use that answer, but use the other one, okay? So that's something that you do want to keep in mind working forward, is that you do need to check those, okay? As we continue, we are going to be looking at proportions and problem solving. Oh, hang on, let me do one more thing first. Before we proceed, let me give you a problem such as this. Sometimes if you have a problem that has variables, people find that to be a little more intimidating. So let's look at P equals R minus C over N. And I want to solve this for the capital letter C. So if I want to get this alone, the first thing we have to do is get rid of that denominator. So if I times both sides by n, that's going to cancel. So I have Pn equals R minus C. I want to have the C alone. And really, too, I want the C to be positive. So I'm going to move my C to the left, and I'm going to move the Pn to the other side. So the C is going to cancel and move to the left. My Pn minus Pn makes that cancel. It moves to the other side, so I have a R minus Pn. And that's it. That's all we got to do. So sometimes you may have a couple of problems where you have just variables, and you're using your same rules that you learned in DMA40 of how to move things across and equals from one side to the other. As we move into our next section and we're looking at proportions, let's start with a simple one here. We have x over x plus 5 and 1 over x minus 3. When you have a proportion, you can cross multiply. So what I'm going to do is I'm going to multiply diagonally. So I'm going to have x times x minus 3. And then diagonally here, I have 1 times x plus 5. So as I distribute, I have x squared minus 3x equals x plus 5. In order to solve for x, I need to make myself a trinomial. So I'm going to move the x and the 5 to the left side. They're going to cancel out here. And I have x squared minus negative 3 minus 1 is negative 4x. And then bring down the minus 5 equals 0. This I'm going to factor into two terms being equal to 0. So 1 times negative 5 is negative 5. So y equals, clear, negative 5 divided by x. Second table, oh, wait a minute, did you notice I accidentally hit it and there was too many x's? So let's go to the end and let's get rid of that extra x. Second table, and our middle number was a negative 4. So that gives me a positive 1 and a minus 5. It gives me a positive 1 and a minus 5. So my solution to this particular problem is, what would make this parenthesis equal to 0? Negative 1. What would make this parenthesis equal to 0? Positive 5. What would make this undefined is a negative 5 and a positive 3. Neither of those make it undefined, so that would be our solution. You will have some problems where you may have similar images. So I have two similar triangles, and they are labeled with 15 and x. This one is 6 and this one is 8. So when you have this, you just have a simple proportion. I'm going to compare the right side of this triangle with the right side of the right triangle. I'm going to compare the bottom of this triangle with the bottom of the other triangle. As I cross multiply, 6 times x is 6x, and then we're going to do 15 times 8, and that's going to give us 120. We're now going to divide both sides by 6, and when you divide by 6, you get a solution of x is equal to 20. So you can set up a simple proportion to solve. Another scenario that you will see, and a hint, you will see this one again on the test. There is a problem where you have Billy who can wax her SUV in 2 hours. Matt can wax the same SUV in 3 hours. If they work together, how long will it take them to work the SUV? Okay, so we have Billy, we have Matt, and we have how long it takes them to work together. So if Billy can wax one SUV in 2 hours, Matt can wax the SUV in 3 hours. They can wax together one SUV in the X unknown amount of time. So this goes back to what we just did in the previous section. We need to find a least common denominator. We have a 2, a 3, and an X. So our least common multiple would be 2 times 3 is 6 and X. So we're going to multiply each term separately by 6x. That'll make our denominator cancel out. So 2 goes into 6 3 times. 3x times 1 is 3x. 3 goes into 6 twice. 2x times 1 is 2x. Here it is the x that cancels, and 6 times 1 is 6. 3x and 2x combined is 5x. Then we're going to divide both sides by the 5. And the answer for x is 6/5. They do not ask you to change it to any other form. So you're going to leave the fraction 6/5 hours as your final solution. So as you're working in section 6, when you set up your problem solving, they will be set up as proportions. Now, please make note, if you look at your pacing guide, your checklist that I gave you, there are a couple of pages in the homework that has some problems regarding upstream or downstream problems. Those problems were specifically omitted, and they are not required for you to do in your workbook. And if you happen to find one still left in the online practice, if it's an upstream or downstream, you may by all means omit those for the time being and work enough other problems to get to the 80%. You are not going to have any test questions on upstream or downstream, so those particular questions, being a little bothersome at times for students and confusing, we did leave those out. Okay, so thank you. Great job today.